So last time we have cleared the meaning of wavefront. Wavefront is a surface. Wavefront is a locus. Wavefront is a set of point. Locus means set of point. Joining all the particles of the medium which receive the light wave simultaneously and which always vibrate in the same phase is called as a wavefront. So depending upon the shape, there are three types: spherical wavefront, plane wavefront and cylindrical wavefront. We have seen the method for obtaining spherical, plane and cylindrical wavefront. Now, in spherical wavefront, there are two subtypes: converging spherical wavefront and diverging spherical wavefront. How they are produced, that we have to explain by this new term called as wave normal. ही नवीन टर्म वेवशी रिलेटेड आता आपल्याला बघायची आहे. The first term that we have seen is a wave front. Now we will see wave normal. So see the name wave normal. There are two words, normal and wave. Normal means perpendicular. So a line drawn perpendicular normal to the wave front is called as a wave normal. नावावरूनच आपल्याला डेफिनेशन तयार करता यायला पाहिजे. So definition is like this: a line drawn normal oblique perpendicular to a wavefront which represents, definition मध्ये दोन पॉइंट आहे. एक म्हणजे त्याची पोझिशन, इट इज ऑलवेज परपेंडिक्युलर टू, अँड व्हॉट इज दिस मीनिंग, विच रिप्रेझेंट्स द डायरेक्शन ऑफ propagation of wave. Propagation of a wave. Like this. A line drawn normal perpendicular to a wavefront which represents the direction of propagation of wave is called a wave normal. Wave normal. Like this. So, explanation. Explanation of wave normal. Now, suppose this is a point source of light kept in homogeneous air medium. So at time t1 second we get a spherical wavefront. At time t2 second the radius goes on increasing. At time t3 second the radius goes on increasing like this. So these are the three spherical wavefronts. Spherical wavefront. Now, if we consider the point P here, then if we join the line SP, then this angle is 90 degree, this is also 90 degree, this is also 90 degree. So SP is a line drawn normal to the spherical wavefront. So it represents the line SP represents the wave normal, and this is the source. So from this source the wave propagates in this direction like this. So this is the line which represents the wave normal. तर या डायरेक्शनने वेव्ह प्रोपोगेट्स होते, या डायरेक्शनने एनर्जी ट्रान्सफर होते. याला आपण हायस्कूल लेवलपासून रे ऑफ लाईट म्हटलेलं आहे. सो वेव्ह नॉर्मल इज अ न्यू नेम. Actually, the basic name is ray of light. Wave normal means ray of light. For example, if we consider a mirror, then if the source is kept here, then the light energy is transferred in this direction. So this is called as incident ray. It is the line along which the wave propagates is called as the ray of light. So this SA is a ray of light. त्यालाच आपण आता वेव्ह नॉर्मल म्हणतो. So wave normal and ray of light both have the same meaning like this. Now if we consider the point Q on the second wavefront, say here. So if we join SQ, then this line is again normal. This angle is 90 degree, this 90 degree. So this line is also representing the wave normal. So light energy is carried in this direction. So SQ is also wave normal. Now if we consider any point R on the third wavefront, then if we join SR, then this angle is 90 degree, this is also 90 degree because these are concentric spheres. So this SR line also represents the direction of wave propagation. So it is also a wave normal like this. So in this figure, SP, SQ, SR are the three SP, SQ, SR are the wave normal. Wave normals from source S like this. So these are the rays of light starting from the S. So in this case, the rays are diverging from each other. The rays are diverging from each other. See this figure. The wave normals are diverging from each other. The angle between them goes this angle is finite and the separation between them is continuously increasing as they move away from the source. So this type of diverging ray produces the diverging spherical wavefront because radius goes on increasing. SP, SQ, SR are the rays of light diverging from each other and producing diverging spherical wavefront. Diverging spherical wavefront like this. Now if the rays converge, suppose I will use this type of arrangement. This is figure 1. I will show figure 6. So this is the convex lens. These are the rays parallel to the principal axis and parallel to each other like this. So we know that when the rays of light are parallel to each other and parallel to the principal axis, they converge at a single point. So suppose they converge here. Like this. So these are the converging rays. Now, for this converging rays, if we draw, this is the focus. If we draw wavefront and wave normal, they are always perpendicular to each other. So this is a wavefront, this is a another wavefront, this is a another wavefront. So these are wavefront, but these are radius goes on decreasing like this. So these are diverging spherical wavefront. These are converging spherical wavefront. Converging spherical wavefront like this. These are the converging rays. They converge at a single point. Converging rays of light. So diverging rays produces diverging spherical wavefront. Converging rays produces the converging spherical wavefront. Therefore, converging rays of light produces converging spherical wavefront. Converging spherical wavefront. Like this. So wavefront and wave normal, they are always perpendicular to each other. Wave normal, wavefront is always perpendicular to wave normal. This is a very important property. So whatever may be the type of the wavefront, the wave normal are always perpendicular to it. So wavefront have three types: spherical wavefront, plane wavefront, and cylindrical wavefront. So if we know the type of the wavefront, then we know the type of the wave normal. So we are to see the types of the wave normal. There are two types of wave normal. Types of wave normal. The first type is radial and second type is parallel. Now how these radial and parallel wave normals are produced, that we have to see separately. Generally, one or two questions related with the level diagram are asked. So on this section, wavefront and wave normal, a level diagram question is asked like this. So I will write down that question. It is given in our notes. Draw a level diagram showing wave normals corresponding to a spherical wavefront, and B plane wavefront. So these two types of wavefront and their corresponding wave normal that we are going to study. Plane wavefront. So let us see this question. First we will see the A part that we have already seen. A part. Spherical wavefront. Spherical wavefront. What are the so if this is a source of light, then from this source we get a spherical wavefront. This is another spherical wavefront at higher time. This is the new spherical wavefront like this. So now at this point, if we take the point P on the first, then SP is a one wave normal. This angle is 90 degree, this angle is 90 degree, this angle is 90 degree. Now, if we consider the point Q, then SQ is another wave normal. This angle is 90 degree, this angle is 90 degree, this angle is 90 degree. Like this. Now, this is the another wave normal. This is the point R. So this angle is 90 degree, this angle is 90 degree, this angle is 90 degree. So SP, SQ, SR are the three wave normals. Now this is A1, B1, C1. These are the spherical wavefront. So labeling is like this. Labeling. So we are using this property. The first point of labeling is S. Point source of light. Point source of light which produces spherical wavefronts. Spherical wavefronts. Second, SP, SQ, SR are spherical wavefront. Spherical wavefront obtained from source S, as different time instant. Third, wavefronts have name A, P, A1, B, Q, B1, C, R, C1 are the spherical wavefront. This is one spherical wavefront, this is another spherical wavefront, and this is the last spherical wavefront. Third one, SP, SQ, SR are the wave normals corresponding to spherical wavefronts, which are radial. आणि हा प्रकार आपण म्हणतो If the wavefront is spherical, then wave normals are radial, like this. So this is the A part that we have completed. Now let us see B part, plane wavefront. So we know the method for obtaining the plane wavefront. Either the source is kept at infinity or source is kept at the principal focus of a convex lens. So we are keeping the source at infinity. So S is the source and it is kept at infinity. So at infinite distance we get a plane wavefront at time t1 second. As time increases we get another spherical plane wavefront. This is another spherical wavefront. So these are the plane wavefronts. So we will use the same name, A1, B1, C1. These are the plane wavefronts. Now, on first wavefront, if we consider the point P here, then if we draw normal, then this angle is 90 degree, this angle is 90 degree, this angle is 90 degree. So this is PP dash is the wave normal. So we can extend this line up to the infinity, like this. Then this is the Q point. So if we draw normal like this, so this angle is 90 degree, this angle is 90 degree, this angle is 90 degree. So QQ dash is another wave normal. And if this is the point R, R dash. So this angle is 90 degree, this is also 90 degree, this is also 90 degree, this is also the third wave normal. So there are three plane wavefront and corresponding there are three wave normals. Now if you see the wave normal PP dash, QQ dash, R dash, they are parallel to each other. So this is the second way. म्हणजे wavefront जर प्लेन असेल तर wave normal parallel येतात आणि wavefront spherical असेल तर wave normal radial येतात. So these are the two types. So the labeling can be given like this. Labeling. First, S is equal to source of light kept at infinite distance. Second, AP1 BQ1 CR the plane wavefronts obtained from source S. And now wave normals. PP dash, QQ dash, RR dash R. The wave normals corresponding to plane wavefronts which are parallel. To each other. फिगरमध्ये दिसतं. So now the types of the wave normals are like this. So wavefront and wave normal are parallel to each other, perpendicular to each other, and therefore now we can complete this table. First, plane wavefront, wave normals are parallel to each other. Second, spherical wavefront, the corresponding wave normals are radial. And third type, cylindrical wavefront, cylindrical wavefront. Then the corresponding wave normals are again radial. Like this. So these are the types of wavefront and wave normals. Now, before going to the Huygen principle, we have to see the types of sources. Primary sources. Primary sources of light. Secondary sources of light. In the principle we require, in Huygen principle we require this concept. So the first point is the definition. The sources that emit the lights of their own which emits light, they produces the light themselves. The sources which emit the light of their own due to their high temperature, temperatures are called primary sources. Second point. Example. The sun stars any body heated flame of a candle. Flame of a candle. This is A group. R. Primary sources. Primary sources. This is one method. Third example. Some sources produces light due to effect of flow of current, like fluorescent tube, electric bulb, TV, torch, arc lamp, etc. There are some sources which produces light because of the chemical reaction. तर आपण दिवाळीमध्ये फटाके उडवतो तर तिथे पण लाईट प्रोड्यूस होतो, पण तिथे मग केमिकल रिॲक्शन किंवा न्यूक्लिअर रिॲक्शन यूज केले जातात. सो केमिकल ऑर न्यूक्लिअर रिॲक्शन्स chemical or nuclear reaction also produces light. In the sources like firecracker, nuclear energy generator, etc. Like this. इथे आपण अजून एक example घेऊ. A lamp in a projector. Like this. Now on this side, so moon is the best example. Moon itself cannot produce light. Only the light is received from sun. It is incident on the surface of moon, and after reflection from the moon, from the surface of the moon, we get the light from the moon. So moon itself is not producing light, but it is only reflecting or scattering the light. So these reflecting sources or scattering sources are considered as the secondary sources. So secondary sources are those sources which do not produce light of their own. Definition. Secondary sources are those sources which does not emit light of their own, which does not produce, which does not emit the light, which does not produce light by their own. Actually what happens, they receive the light energy from somewhere, but receive light energy from some other source and and either reflect or scatter it, and either reflect or scatter the incident light. Around it. So they are not real sources. They behave as a sources temporarily, like this. So we will see some more example of secondary sources. Second example. Moon is the best example. At the night we get the light from the moon. The planets reflecting surfaces, reflecting objects, screen in theater, etc. Like this. So, generally, secondary sources are extended sources, means they produce the cylindrical wavefront. Extended sources of light producing the cylindrical wavefront. So in Huygen's principle, we are using the concept of secondary sources, and therefore first we have seen the meaning of primary and secondary sources. So one example is this. Now after this table explanation, the lamp in a projector machine is a primary source. And all the points on the screen in cinema theater reflect the light towards the spectators. Therefore, the points on screen are secondary sources. Secondary sources. This is one point. B. The light waves produced by primary sources. Primary sources are called as primary waves. Are called primary waves, and waves produced by secondary sources are called secondary waves. Secondary waves. So these 2 points are important. This is important point. Primary waves produced by primary sources, secondary waves produced by secondary sources, like this. Now we can explain Huygen principle in detail, and what to use the Huygen principle for the construction of spherical wavefront and plane wavefront. So that is the application side of the Huygen principle. So next time we will see the Huygen's principle.